What if the weather itself could be hacked? We're not talking about a movie plot. We're talking about a real emerging threat in our hyper-connected world. Imagine a world where a line of code could trigger a drought, or a keystroke could unleash a devastating flood. This is the story of The Hackers Who Stole the Weather, an exploration into one of the most chilling possibilities of the digital age. Cybercriminals targeting the very systems that control our climate. All around the globe, from the arid plains of the Middle East to the farmlands of North America, humanity is in a race against time. We're deploying incredible technology to manage our most precious resource, the weather. We use cloud seeding to bring rain to parched lands, smart irrigation systems that feed millions, and a complex network of satellites and IoT sensors that constantly monitor and predict our planet's climate patterns. Our environment is more digitally connected than ever before. But with that connection comes a terrifying vulnerability. Every sensor, every satellite, every line of code is a potential doorway for those with malicious intent. This story imagines a cybercrime ring bold enough to exploit those weaknesses. They aren't interested in your bank account. Their ambition is far greater. They seek to control the sky. Through a sophisticated campaign of digital sabotage, these hackers gain access to weather modification technology, holding entire regions hostage. Their demands are simple: pay up or face ecological collapse. They don't just threaten data. They threaten livelihoods, economies, and human survival itself. Let's trace how such an attack could unfold. It starts small, almost invisibly. A single phishing email sent to an engineer at a national weather agency. A compromised password. It seems insignificant, but it's the key that unlocks the kingdom. Once inside, the hackers move silently through the network, escalating their privileges. They are digital ghosts, mapping the infrastructure that connects ground-based sensors to orbiting satellites. Their target? The command and control systems for a regional cloud seeding operation designed to combat a prolonged drought. For weeks, nothing happens. The hackers wait, studying the patterns, learning the protocols. Then, on the eve of a major scheduled operation to bring much-needed rain to a struggling agricultural heartland, they make their move. The pilots are in the air, the silver iodide flares are ready, but the command from the ground never comes. Or worse, the wrong command comes. Instead of seeding the clouds to produce gentle, life-giving rain, the system is manipulated to disperse the cloud cover entirely, intensifying the drought. The hackers have turned a tool of hope into a weapon of despair. Simultaneously, they target the data streams. Weather prediction models, fed by thousands of IoT stations, are corrupted with false information. Forecasts become unreliable, chaotic. A storm that was predicted to be a minor squall is suddenly a Category 3 hurricane, leaving coastal communities with no time to prepare. The public's trust in official warnings evaporates. Panic sets in. The hackers have not only seized control of the weather, they've weaponized information itself. This isn't science fiction. Cybersecurity specialists have been warning about these exact scenarios for years. The systems we rely on for our food supply, water distribution, and disaster response are already frequent targets of cyber attacks. We've seen hackers shut down pipelines, cripple electrical grids, and disrupt supply chains. The technical leap to manipulating climate technology is smaller than we'd like to believe. To understand how, we need to look at the architecture of these systems. Weather modification relies on a chain of technology. It begins with data collection from weather stations and satellites. This data is fed into complex AI models that predict atmospheric conditions and identify opportunities for intervention. Finally, commands are sent to operational units, like aircraft for cloud seeding or automated dam controls. A vulnerability at any point in this chain can compromise the entire system. Hackers could use a man-in-the-middle attack to intercept and alter satellite data, making AI models blind or feeding them a distorted reality. They could deploy ransomware on the central servers that run these climate models, locking out legitimate operators until a hefty price is paid. Or, As in our scenario, they could gain direct control of the operational tech, turning our own tools against us. Think about it. A nation's ability to produce food is increasingly tied to smart agriculture. Irrigation systems are automated based on soil moisture data from IoT sensors. What happens when a hacker spoofs that data, telling the system the soil is wet when it's bone dry? The crops fail, millions go hungry. It's a silent, devastating form of warfare, fought with keyboards instead of bombs. But beyond the code and the technical vulnerabilities, this is a deeply human story. Imagine you're a farmer who has invested your life savings into your land. You've placed your trust in a new technology that promises to deliver rain and ensure a good harvest. Suddenly that promise is broken. The rain never comes. Your fields turn to dust. You watch your livelihood wither away, not because of a natural disaster, but because of a criminal enterprise halfway across the world. You are powerless, a victim of an invisible enemy who can summon or silence the rain with a keystroke. Think of the families living in a coastal city, told to expect a light shower, only to be hit by a deluge unleashed by a hacked weather system. Their homes are flooded, their lives upended. Who is to blame? The government? The tech company? Or the anonymous hackers who treated their city like a pawn in a global extortion scheme? This raises unsettling questions. Who truly controls the weather when the machines are hacked? What happens when cybercrime graduates from stealing money to reshaping nature itself? The ethical dilemmas are profound. Governments are already investing in geoengineering as a potential solution to climate change. These are large-scale interventions designed to alter the Earth's climate system, such as solar radiation management. The power to dim the sun or change ocean currents is monumental. If these systems are vulnerable to cyberattacks, the consequences are almost unimaginable. A rogue actor could trigger an ice age or create a runaway greenhouse effect, not out of malice, but perhaps even by accident, a single bug in the code. This forces us to confront a new reality. The digital infrastructure that underpins our modern world is now intertwined with the planet's natural systems. Protecting our climate is no longer just about reducing emissions. It's also about securing the code that manages it. We need a new paradigm of cybersecurity, one that treats our climate technology with the same level of protection we give our nuclear launch codes. This means building security in from the ground up, not as an afterthought. It means constant monitoring, international cooperation, and creating resilient systems that can withstand and recover from an attack. The story of the hackers who stole the weather is a cautionary tale. It is a warning about the unintended consequences of our own ingenuity. As we continue to build a smarter, more connected world, we must also prepare for smarter, more dangerous threats. The future of our planet may depend not just on our ability to innovate, but on our ability to protect those innovations from the gathering storm of cybercrime. The fight for our future will be waged on two fronts, in the physical world and on the digital frontier. We must be ready. Thank you for watching this deep dive into one of today's most critical emerging threats. If you found this exploration insightful, please consider liking this video and subscribing to our channel for more content that challenges your perspective. Stay curious, stay informed, and stay safe.